as you did yesterday. To do that, you just distribute. A couple things to remember. So when you're distributing, you have to multiply what's on the outside by each thing on the inside. If the variable has the same base, what do we do with our exponents? We add them. So if the variables are the same, you can add your exponents. And the numbers in front, which are called the coefficients, you multiply the coefficients. So just make sure when you distribute that you multiply what's on the outside to each term on the inside. Okay, we're going to go ahead and we're doing one example. I'll show you two ways to do it. You can choose which you prefer. Okay, so if we're just distributing, then I'm multiplying 5n by all three terms. So 5n times 3n squared. Multiply the coefficients, the numbers in front. So 5 times 3 gives me 15. And then the variables are the same, n and n. So add your exponents. This n has a 1. So yes, add your exponents, you get n to the 4th. Since we're multiplying and have the same base. Okay, keep going. 5n now times negative n squared. That's a negative 1 n squared. So my coefficient would be negative 5. Add my exponents, it would be n to the what? Third power. 1 plus 3. And the last one, 8 times 5n would give me 40n. So all you're doing is distributing. It's just a little bit more complicated because you have to add your exponents. And make sure you multiply the numbers in front correctly. Okay, if you prefer what we did yesterday, you could also make a box. So this is like the box method, just like you did with lattice in elementary school. You can do the same type of thing. You could do 5n. You don't have to do this. I really don't care which way you do it though. 5n, and that would be multiplied by 3 terms. So put 3 boxes. 3n cubed minus n squared plus 8. And then you would just do the same multiplication. So in the first box, the area would be 15n to the 4th. And the second would be negative 5n to the 3rd. And the last one would be 40n. So you get the same thing. Whatever makes more sense to you, I do not care. If the first way makes sense, then great, do that. Okay, just real quick. This degree is 4. So what's the word we use for the degree if we're going to name this? Quartic. So this is a quartic. And it has 3 terms. Trinomial. Just for fun, to keep you doing that. We're going to keep doing it as much as possible. Okay, now let's talk about the GCF. How do I factor the greatest common factor from a polynomial? Okay, simply take out the greatest term that they all divide by evenly. So that's what you guys were doing on that last page. Okay. This example, we're just going to find the GCF. We're not actually going to factor it. So look at the first one, 9x to the fourth plus 45x squared minus 18x. First, let's look at the numbers. What is the greatest number that all three terms, 9, 45, negative 18, what's the greatest number they can all divide by? 9, okay? So that would be your number for your GCF. And you're not always going to get a number and a variable, but sometimes you will. Now look at the variables. What's the greatest variable that you can take out? X. You cannot take out x squared because, see, look at the last one. It just has an x, so the most you can take out is just one x. This is your GCF. Yes?
Would there be an equation where like these cannot, like this cannot go into that?
Like they don't have anything.
No
if there's nothing in common, sure, yeah. You'll see that probably later this week. Okay, look at the next one. Let's start by looking at the numbers. If the first number is negative, you want to take out a negative. So we're going to take out a negative number. But 72, 32, and 56, what is their greatest common factor? What can they all divide by evenly with the highest number? Think back to your math facts. Anybody else? What do we say? It's 8. It is 8. 9 times 8 is 72. 8 times 4 is 32. 8 times 7 is 56. That's the highest one. Okay, so 8. Now let's look at the u's. How many u's can I take out? 1. And can I take out any v's? Do all three terms have a v? No, so you can't do that. So the only thing that you can take out would be negative 8u. Okay, there's a question at the bottom of the page. So factoring again, I just want you to add one thing. So whenever you take out the GCF, and we've done this a little bit yesterday, the GCF goes in the outside, and then it's whatever is left is on the inside to multiply to get it. When I say GCF, I mean greatest common factor, the largest thing they can all divide by. Okay, we're going to do, I think, 2 examples together, and then I might let you try the third one, which is the most complicated one. I'll let you try that one on your own. Okay, look at this first one. Now we're actually going to factor. Notice how I said factor using the GCF? You actually have to put the GCF outside, and then whatever is left in parentheses. If I say factor, I mean I want something outside and then parentheses. Okay, look at the numbers first. 36, 42, 12. Tell your partner, what can they all divide by? What's the highest number? Thank you, I heard it. 6. N squared, n cubed. What's the highest amount of n's you can take out? 1, 2, or 3? 1. So 6n is your GCF. Now in parentheses, you'll have what's left to multiply to get that. 6n times what gives me 36n? 6. Okay, so that's done. 6n times what gives me 42n squared? 7n. And then 6n times what gives me negative 12n cubed? Negative 2. How many n's? N squared. And if you can always double check your work by distributing out and making sure that it matches. If it doesn't match, when you distribute, then something is wrong. Yes?
How does the negative 2n squared on the end reach 12 into the cubed?
Sure, so 6 times negative 2 is negative 12. And then n to the first times n to the second is n to the third. You put those together. Okay, we're going to do one more together, and then I'm going to let you try the third one, because it's good for you. Okay, look at your numbers, 18, 12, and 30. Tell your partner, please, what's the highest number? I heard 6. We agree? Okay, now look at your x's. You have x, x squared, and x to the 7th. What's the highest amount of x's you can take out? 1. Now look at your y's. Y squared, y squared, y squared. What's the highest amount of y squares you can take out? 2 of them, so y squared. There's your GCF. And then you put whatever is left in parentheses. So that would have to multiply by 3. And then to get the second one, 6 times what is 12? 2, okay. You already took out the y squared, so x times what is x squared?
Another x.
Right. And then the last one, 6 times what is 30? X times what is x to the 7th? X to the 6th. Awesome. Okay, I would like you to try the next one. Woo! One thing at a time. Numbers, A, B, C, go there. One thing at a time. Do the next one with your partner, please.
No way, bro. They're just saying no way.
You can do it. Try. Just try.
Bro, Superman can't even do one.
Your number should be 9. Your A values are A to the 10th, A to the 3rd, A to the 3rd, A to the 4th. So the highest thing that you can take out is A to the 3rd, because you can't do anything past that, because that's the only thing that they all have in common. That's the highest one they all have. They all have at least A to the 3rd. Think about it that way. We've got B to the 5th, B to the 10th, B to the 4th, and B to the 5th. So they all have in common at least B to the 4th. And then your C's. What's the most that they all have in common for C?
3 zeros.
1.
That's on that one.
Okay, and then here's what you should have remaining. If you've already factored it, I'm impressed. Okay, that would leave you with 10A to the 7th BC squared plus 6B to the 6th plus 6c, hold on, did I mess something? Oh, 6c squared plus 9ab. Anybody get it?
Can we get a round of applause for Q?
Woo, woo, woo! If you got it, that's really good. Okay. Last thing. I care most. Could you get the GCF out of that? If you did, then that's good. I know that's a tough one. Last thing. Okay, this is applying geometry in algebra, which is what the EOC likes to do. Okay, here we go. A helicopter landing pad, or a helipad, is sometimes marked with a circle, true fact, inside of a square, also true, so that it is visible from the air. What is the area of the shaded region of the helipad at the right? Write your answer in factored form. Okay, if you forgot, the area of a circle is pi r squared. Pi times the radius squared. What's the area of a rectangle or a square? Length times width. Okay. So your area of the circle, your radius, is from the center to the outside. So our radius is x. So my area of the circle is pi x squared. This is a square. So if this side is 2x, then the other side is also 2x. So length times width would be 2x times 2x. If I multiply 2x times 2x, then I'm multiplying the numbers, so the coefficients together, and then I add the exponents. So the area of the square is what? 4x squared. Okay, what do I do to get the shaded part? I know what the square is, I know what the circle is, so how could I get the shaded part only? I heard it. What can I do? Yes. So take your square. So the area of the whole thing would be take the square area, 4x squared, minus the circle area, pi x squared. It says write your answer in factored form. So you need to factor this with your GCF. What is my GCF? X squared. So my area would be, if I factor out x squared, it would be x squared times 4 minus pi. So that is factored form. Factored form has parentheses. So when I ask for factored form, make sure that you have parentheses.